this session is how to cloud native before going to the cloud. So you can focus how to cloud native, how to have cloud native methodologies, approaches, tools, but in a non-cloud setting, so outside of the cloud. My name is Ricardo. I'm a cloud native engineer at Continuous Solutions. And this is the agenda for this talk today. I'll first start by discussing a little bit what cloud native is. And I can tell you that this was going to be the most fun part, with lots of interaction, but last night I realized that my talk was going to last 1 hour with all this interaction. So there'll be very little interaction. However, you can speak to me afterwards outside. So I'll start by talking about what I think is cloud native. I'll go then to the journey of a company that's a little bit traditional and is thinking about perhaps going towards this direction of cloud native. And then I'll finish with my home lab story, which is my on-prem company. Okay, so what is cloud native? It's kind of a mystical concept. It's a buzzword, and we all love and hate buzzwords. But I quite like cloud native, and I have this definition, which is not really a definition, but it's more of a thought. I see cloud native as a group of approaches, of tools, of principles, of methodologies that were simply advanced, were supercharged by cloud computing. That's it. So cloud computing came to exist, it promoted a bunch of different things, and now we have this thing called cloud native. The brilliant thing is that cloud native can be applied in cloud and outside of the cloud. Now, what were the things that cloud native contribute towards? There's a lot of debate, and as I said, this was going to be the most interesting, well, not the most interesting, the part with the more debate. But there's a lot of talk about what cloud native is, and here I'll just tell you what I think it is. What are those features or those aspects? We start off with scalability, which is the ability of your system to expand or contract when load or demand goes up or down. That's one thing. Quick time to market, the time between ideation of a feature and the time that feature is in production. So in cloud native world, you try to compress that. That's another thing that I think is very important. Immutable infra, super important. In a little while, I'll talk a little bit more about that. But this is a little bit more technical, so I won't go into details now. Observability in cloud native world, as is mostly composed of distributed systems. Observability is super important. You need to know the state of your system, of your distributed system. And so you have metrics, you have logs, you have tracing, you have visualization. All those things are super important in cloud native. Availability, you need your systems to have very high uptime. Resilience, your systems need to be able to self-heal after there's a catastrophe, and then it needs to automatically recover from that. Reliability, not only when I go to the tube machine and I buy a ticket, I can put a coin inside, but I still need a ticket. So I need the system to work as expected, not just to be online. I need it to be doing what I want it to do. And finally, team topologies. Everyone is recommending it. I recommend it as well. I think it's a great book, and it really helps companies to move more towards product-led mindset. It focuses on reducing cognitive load for developers, which is very, very important, I think. And also talks a lot about platform engineering, which we all care about. For the rest of this presentation, and particularly for the part about working with a company, I'll focus on 3 of these aspects, because we could spend the whole week talking about all those things. But I'll focus on scalability, which I think is very important. I'll focus on the quick time to market, and I'll focus on immutable infra. Okay. I just realized I didn't start the timer.
I got you, don't worry.
Okay. So this is the second part of the session. And I'll be talking to you about how a company who's on-prem, who's a bit traditional, might start their journey towards cloud native. So, in the beginning, we have this company. Most of its applications, or even it might even just have one application, and its infrastructure is it's a monolith. It's very rigid. It's very intertwined. People are very afraid to touch it because if you touch it, you break it. So very rigid, but at the same time, super fragile. This is a common situation in many companies. The first steps. Surprisingly enough, I'm not talking about monolith to microservices, even though that's also part of the story. But the first steps, as in my life, how I see when you have a big problem, you try to break it into smaller problems, and then you go at it individually. And this will be the same thing here. So if this were my company, or if I was going to advise this company, then I'll focus on some of those smaller problems. Right. So we could start with the first aspect I mentioned before, scalability. So I get to this company. The starting point is this company has hardware, has servers. Each server has a few applications running, or maybe one application. How does it scale? Well, it's difficult. If you have increasing demand, then you'll have to call the IT team and please buy more servers. That will take you a few weeks, a few months, and that's terrible. That's boring. What will developers also do in the meantime? You need more hardware. You also have the reverse problem, which is what if demand is actually quite low, and then you can't easily move applications from one server to another server, then you're going to have unused resources, so that's really wasteful. Companies like this don't exist that much these days. Most companies these days have virtualization, which in the early 2000s really was a game changer because it allowed you to virtualize everything, virtualize compute, storage, networking. And it really made a big difference to solve these problems of, if you have bigger demand, then you can just create extra VMs. Of course, you still have to, if you need more hardware, you still can do it. But the big benefit here is that maybe some applications have more demand, some applications have less demand, and then you can put more resources on the parts that you actually need to do that. However, something that's not very common, like these days, even though, I don't know if all companies, but a big chunk of companies have virtualization, a virtualization layer, they don't have auto-scaling, which is something that the cloud, it's a wonderful thing, right? You just go into auto-scaling groups, you just do a couple lines of configuration, then all of a sudden, if you have more demand, you have more servers popping in. In this company, I'll probably tell them, okay, why don't you start creating some scripts with your virtualization layer? So for instance, if you use VMware vSphere, you can also work with OpenStack. You can create scripts that will do this for you. The downside of this is that there's a little bit of maintenance, so it's not super straightforward, but you can still have this auto-scaling ability. The next step then, which is the exciting step, is when you bring in container orchestration, be it Mesos or be it Kubernetes like I'm depicting there. And this is a whole new world. It's a wonderful world. Many of us work there. The big difference here is that by default, there's very little configuration you need to do. You have a cluster running, and then if there's more demand, you can have both vertical scaling, so your pods, your resources your pods get more resources associated with them, or you can also have horizontal scaling, so you add more instances of the same pods, of the same services. All of this automatically. There's very little management of infrastructure. There's also another feature, which is cluster auto-scaling, which is also very common in the cloud, where if you have a Kubernetes cluster and you need more nodes, more VMs, that can be done. Again, on-prem, you can still also do that. There's also tools. You can still work with VMware or OpenStack and get more VMs added created and added onto your cluster. And that's pretty cool, I think. right? Time to market. So traditionally, time to market was a challenge, right? I mean, I still remember having colleagues, luckily it was never me, I'm really grateful for that, but having colleagues once a month, once every 3 months, all right, I'm taking the weekend off, we're gonna do a release, shut down everything, and then high pressure, high stress, then you go for drinks for a whole day to compensate. And that's terrible, that was really rough. But more than that, so that's part of the story. But there are two big problems I see in traditional way of doing this, which is you tend to have a monolith. So everything, as I said before, everything is intertwined. So developers, they don't know everything. The cognitive load is very high. They're afraid of making changes. So that part of the process is very slow. And at the same time, you have long-lived testing environments that they keep on drifting and are different from production and from your development environment. So from you to get an idea, you're afraid of touching the code base because, yeah, who knows what's going to happen? And then there's so many processes, so many steps you need to get to QA staging oftentimes like in a manual fashion, that it just takes a lot of time to get to production. So what can this company start doing? I would probably suggest this company to don't move straight away to, well, if you do want to do it, but you don't need to move straight away onto microservices. You can start reducing the cognitive load simply by using something like services-oriented architecture, and then giving to your developers, saying, okay, now you own this bit of the code base, and you own this bit of the code base, and you own this bit of the code base. That will improve things a lot. People will be a lot more confident. And in a similar fashion to microservices, in between those modules, you can still have like kind of stable interfaces, which makes everyone a little bit more confident. You still, though, have the problem of this long-lived testing environments, which they're always like they're pets, they're not cattle, and they really slow down the deployment process. Now, another thing that cloud really contributed towards this aspect of cloud native is that it just developed a lot of tools for CI/CD, for continuous integration and continuous development. So what I would suggest to this company is that, yes, eventually start moving towards microservices, which again will further decrease the cognitive load on the developers, which is great. But then also start applying some of those CI/CD tools that make it very fast, much faster, and automated to go from development onto production. So in fact, if you look at it from outside, it looks as if there's no testing stage. You just have your local development environment and you have production, perhaps pre-prod and then production. But what happens here is, again, taking learning from cloud, you start using ephemeral environments that those pipelines just spin up or down. So you spin up a testing environment, which quickly, and just for that pipeline, will run all the tests that it has to run, and then shuts it down. This is orders of magnitude faster than the old days. So in the old days, it was every 3 months, every month, whatever. Now we have multiple deployments a day directly to production, or you can have. And this is technology, is methodology, and all of this can be applied on-prem. You don't need to be on the cloud to have this working. Okay, immutable infrastructure. Some people say, you say immutable infrastructure, you say, huh? But immutable infrastructure, I think it's really cool, and it's a really essential part of cloud native. Immutable infrastructure, the basic idea is that you don't apply configuration to existing resource or existing servers, even applications. So if there's any change, you check away the old version and you put a new version. You create a new version. So in the old days, you have an engineer provisioning a server with version 1, version 2, version 1. Then let's say she found out that she has to do a patch. Then she has to SSH into the server, makes the changes that she wants to make, reboot the server, and voila, we have a new server. We have version 2 server. Now, of course, as many of you probably know, this is terrible. Like, error prone. It's like super boring. Like, how can you spend your life doing this? And it's not fun. So in this company, what I'll probably suggest would be that, okay, we can still continue provisioning servers manually as we get them, let's put them in place manually, but at least let's start configuring them automatically. Let's use tools like Ansible playbooks just to automate the configuration. And that's a big improvement. So then when you have to make a patch, you just change the configuration, the script that you have, the Ansible playbook, and you apply it over the existing server. Again, you reboot it, and then you have a new version. And this is very nice. You've automated part of the process. You still have manual labor, but is faster. You're more confident. You keep track you keep a better track of the state of your servers, and that you sleep better at night with this. But next step. And then again, taking the ideas from the cloud and from like infrastructure as code tools as Terraform, which are really wonderful. You start treating your infrastructure, your servers as codes. Instead of manually having to provision your servers, you just write a script and you tell your on-prem, let's say your hypervisor, I want these VMs, I want this networking, I want this storage, this compute. And that magically appears. Very nice. There's a problem then. There's a patch as before. What am I going to do? I'm simply going to update the desired state that I want. And then what's going to happen? Crucially, I'm not going to apply these changes onto the old server. Instead, I'll simply destroy the old server and a new server will appear. This is exactly what happens on the cloud, but I'm making this on-prem. And you feel I surely feel very powerful when I'm doing these type of things. Then there are all the other aspects, but I think just starting with these three, immutable infrastructure, scalability, and time to market, I think this already creates big improvements on the company. At the client I'm working now, our team, since they joined, they reduced not time to market exactly, but the amount of time it takes for you to get some resource, like some servers, from weeks to, I think at the moment, it's 55 minutes for you to get your whole, many servers ready for you to work. And that's really great. I'll go now to my homelab journey, which is the most fun part of the talk. It's the reason why I decided to make this talk, because I did the homelab and then I realized, I can do a talk about it. Why did I do the homelab? I really enjoy tinkering with hardware, seeing lights flash, and that just makes my day. I really like hardware. I also like to test the software I use at work. I could use work environments, but many times there's a lot of configuration that you don't know. When you own the homelab, you own everything, and that makes such a big difference. I can read a book, and I need to read it 3 times before I can apprehend anything. Homelabbing, every single problem is a lesson learned. So I'll advise. I also found out there's a massive community of homelabbers. I'll really suggest anyone to try it. It's really wonderful, and people are very supportive. How to homelab? Just noticing that I was really worried about time, but it's going well. I still have time, so I can slow down a little bit and enjoy it. And I cut so many slides that were wonderful. So how do you homelab? This is my setup. As you can maybe guess, this is not the usual setup. The usual setup is terrible. My wife wouldn't allow it outside of my little office. So for this sake, I decided to take some photos in the living room. And it all started with some old laptops I had at home. I then actually went to my father-in-law to convince him to give me a very old laptop that had some personal attachment to it, but I was able to get it. And then as things progressed, I started to get more. I bought like a couple Nooks, like those small laptops there, computers there, and I also have a Switch here. Why did I do it? As I said before, there are a number of reasons, but why not the cloud specifically? I have this kind of thrift mentality as well, which given me a lot of problems in the past as well. But I always prefer to, if I don't need to pay for something, if I can leverage existing hardware, I'll just do it. And so that's probably the main reason why I also went through this route. Right, so now, party time. And I was just discussing with people, how is it possible that some people do live demos, which I was talking, I don't know if you saw Adam's presentation, and he was just telling me that he didn't really sleep very well because he was worried that the Docker God is going to fail him. So I just record things, and I have no problem. Okay, so this is my setup. So what you saw there, I had 5 physical nodes. So I had two NUCs and I had 3 old laptops. Here I only put 3 to work. I used Proxmox because it has a really cool community around it. It's a hypervisor of type 1, so it's on the bare metal, and it's quite easy to set up. So I manually had to install Proxmox on all the servers, and then I had to run some simple scripts just to put them all together in the same cluster. So what you can see here on the left is the Proxmox UI. On the right is all the code that I have to deploy everything. What I have here is basically there's some Terraform templates, and there's some Ansible there's an Ansible playbook. The way this works is quite simple. I have a make file at the bottom, and then when I run make cluster, it will first call Terraform to create the VMs, and then it will run the Ansible playbooks to do configurations. And in this case, configuration is mostly deploying RKey2, which for the ones of you that don't know, it's a Kubernetes distribution by Rancher, which I'm using currently at work. It's very focused in security. So let's press play. So this is now, it takes 17 minutes. I think we can all skip coffee break, right? There's no problem. Right, so this, okay. So on the right, I will be running make cluster. And as I was saying, it will start by running Terraform apply. It will create all the resources that I need. And there you go. Eventually, Ansible kicks in. You have Ansible's, oh, right. And here on the left, you see that you have those VMs, 100, 102, and 103 are all the VMs. This is just like the cloud. I mean, to me, it was like, awesome. You have those VMs being created by the script. So we keep on going. Ansible is doing its own thing. That's very nice. Thank you very much. And I think it's around minute 13 where it gets done. There you go, 13 minutes, and we have a fully functional RKey cluster going. I was like, wow, very cool. Now I'm just showing you, I've just SSH into the master nodes, changing here the kubeconfig location because of RKey2 is a little bit different. But then there you go, get kubectl get nodes. I just have an alias as part of the Ansible playbook. We get the nodes here. You get nodes, you get pods. There are still, some of them are still being created, but eventually they will be all running, as you can see there. You can also get deployments, all the shebang. End of the day, 5 minutes. Make cluster, destroy. This is not automated, like you need to actually write yes, just in case, to double check. And your cluster is being sent down. And as you can see there, 100, 102, and 103, they were there. They're no longer there. And there you go. That was the demo. It was really like stress-free. But not the presentation, so we'll have to clap again. Apologies for that. So I have this controversial message here. Forget about the cloud in cloud native. Yeah, I'll forget about the cloud in cloud native, at least until cloud makes sense for your use case. Really, I'd say think about it. Since we still have, well, maybe I'll leave it for questions. Yeah, I was going to tell you like what things you could, why perhaps it would make sense for you to wait a little bit, but you can just check online. There's a bunch of, like, so much stuff going on at the moment about why companies are not going to the cloud or getting out of the cloud, that maybe we can leave that for discussion. And to conclude, yeah, that's it. Thank you so much.